In order to better understand the nature of the antivector, it is necessary to revisit the square within a square. One quadrant of the square within a square is defined by a length of 1, with diagonals defined by the square root of 2 divided by 2, which in decimal form is 0.7071. From the reference corner, the vertical corner is defined by the perception of 1, and the diagonal corner is defined by the perception of the square root of 2. These two corners have opposing perceptions along the exterior edge. From the vertical corner, the perception to the center is 0.4142, and from the diagonal corner, the perception of the center is 0.5858, where the ratio of 0.5858 divided by 0.4142 equals the square root of 2. The perceived division of the exterior boundary line creates a new boundary line at pi over 8 radians, or 22.5 degrees from the reference. The diagonal line is similarly divided, with the perception from the vertical corner being 0.4142 and the perception from the diagonal center being 0.2929, where the ratio of 0.4142 divided by 0.2929 equals the square root of 2. Given that each quadrant will be similarly divided, there will exist 4 new boundary lines dividing spacetime. Each new boundary line represents a pair of perspectives that must be equalized. In order to accomplish this, the fields reflect their geometry over the boundary lines, resulting in the formation of a new square within a square that is rotated pi over 4 radians from the reference square. The relationship between the two squares is defined by the lengths separating them. Two of these lengths are recognizable as phi and e. 1.6330 is within the field of phi, and 2.7142, which is the identity of 1.35719, is within the field of e. The phi and e vectors define perpendicular vectors, which define a new quadrant division of spacetime. Given that phi and e fall within the range of antivectors, then antivectors will be defined collectively as phi group vectors, or simply phi vectors. And the new square within a square that is rotated pi over 4 radians from the reference will be defined as a phi square within a square. Each new number introduced into spacetime defines a fundamental property of spacetime. The number 5 is the first number to be introduced other than 1 and 3. Just as with the number 3, the number 5 has 4 reference states, a number and a fraction referenced to time, and a number and a fraction referenced to distance. The number 5 is fundamentally referenced to the equalized field or sine wave. The position of 5 falls within the amplitude quadrant field, which means the number 5 is fundamentally defined as an amplitude. Given that the number 5 is defined relative to the equalized field, it will need to be equalized. The number 5 falls 13.7% away from the 2 to the 4/12 vector, which is within the 25% field limit of that vector. The number 5 is then fundamentally referenced to the 2 to the 4/12 vector. The 2 to the 4/12 vector is also represented as 2 to the 1/3 vector, which defines 1/3 of a rotation around the equalized field and identifies the 3 reference axes. The number 5 then defines an axis rotation around the equalized field. The 2 to the n/3 series is a series that divides number space equally by thirds. For example, the 2 to the n/12 circle is divided into 3 equal sections, and the 3 to the n power circle is also divided into 3 equal sections. When the 2 to the n over 3 series completes a circle, the vector orientation has been reversed. For example, starting at 1, or 2 to the 0 over 3, the position is a mass node. Traveling around the circle to the 2 to the 3 over 3 position, it has transformed into an energy node. The number 5 then has a common relationship with the square root of 2 and the number 2. The number 7 is the first number to be introduced other than 1, 3, and 5. Just as with the numbers 3 and 5, the number 7 has 4 reference states: a number and a fraction referenced to time, and a number and a fraction referenced to distance. The number 7 is fundamentally referenced to the equalized field or sine wave. The position of 7 falls within the amplitude quadrant field, which means the number 7 is fundamentally defined as an amplitude. Given that the number 7 is defined relative to the equalized field, it will also need to be equalized. The number 7 falls 18.8% away from the 2 to the 19/24 antivector, which is within the 25% field limit. The number 7 is then fundamentally referenced to the 2 to the 19/24 antivector. The antivector wave is an amplitude wave, which means it begins with an amplitude and ends with an amplitude. In other words, the antivector wave is the inversion of the vector wave in all respects. Given that the number 7 is the first number to introduce antivectors, then the 8:7 ratio defines a vector-antivector relationship. The 8:7 ratio is defined by the equalized 2 to the 5/24 vector. The 2 to the 5n over 24 series then defines a progression that will define all 12 vectors and all 12 antivectors, as well as define a natural path of travel between them. The 2 to the 5n over 24 series then defines a vector-antivector circle. The vector-antivector circle can then be reduced to the equalized field between 1 and 2. The result is 2 circles. The 2 circles are easier to understand when viewed in color. The colors on the upper side of the plane define vectors. The colors on the underside of the plane define antivectors. In between each color vector on the upper side of the plane is a neutral gray area that is the inversion of the antivector. On the underside of the plane, in between the colored antivectors, is also a neutral gray area that is the inversion of the colored vectors.